the four gentlemen here, you are atoms in a lattice, right? So let's assume you're copper atoms. So I put you together in a lattice, and each of you is now giving away one electron. Because the piece of copper is a metal, the electrons have to flow. Okay? So if you were to stay here, okay, you stay here. Eric, you can stay here. You can, if you would like to stay here, and Patrick, if you stay here. Okay, good. So now you're positively charged. Are you charged? Obviously, right? Okay, so now you're positively charged. These are copper atoms, but if they form a metal, they actually give one electron away. If they give one electron away, they're positively charged. Okay. So now, you are two electrons, right, that move through this lattice. Now, electrons have an interesting property, namely they spin. So you can imagine, I don't make you spin now because I don't want you to get dizzy, but if you came over here, please. So, we have now 8 volunteers. Yeah. So, she's the electron, she is negatively charged. Electrons spin. And the two electrons, which if form the Cooper pair, actually spin in different ways, right? The Earth spins, and if I use the right-hand rule, if it spins that way, right, I can associate a direction of spin with it. Okay? So if you spin now, and you don't have to, and you flow through the metal, then, if you would follow me, now this, let's say, clockwise spinning electron has arrived in the center of these four positively charged atoms. Okay? So what do you think what happens now? She's negatively charged, they are positively charged. Right, so you're all attracted to this negatively charged electron. So take a step in, please. So now, she's an electron. What mass is bigger, the one of the electron or the one of the atom? Of the atom, right? So you're very quick. You now exit this way. Okay. So what this electron has now actually done is it has attracted the atom, it has distorted the lattice, and it has created locally a positive charge. Right? So now our other electron, which spins in the opposite direction, don't spin, comes along and is attracted by this local positive charge. Right? So now you come in here. Now she's in the center. And so what we now have is that one electron created a positive charge. It's gone because it's so fast. And this positive charge now attracts a second electron, which effectively creates now an attraction between these two electrons. Now it actually turns out that the electrons which are most attracted do not only spin in opposite directions, but also move in opposite directions. So what you need in order to create actually a Cooper pair is not simply two electrons, but you also need a lattice of positively charged atoms. And because you distort it, you create what you call a lattice vibration or a phonon. So phonons are basically, if you want, the glue, the mediator of this attractive interaction between the two electrons. Thank you very much for your help.